So this is what we have happening this week. I'm trying to get my levitator going here. There we go. And that's magnetism at work. So I'll leave that sitting there. Nope, can't see it if it's there. Oh, I tapped it with my nail. Yep, dropped it. All right, so let's get to what's happening this week. So we have the waves inquiry stations that were due. We have wave boundary interactions were due on Wednesday. And then this was a close reading. This was not required. It was about different wave types. I think it's an important part of understanding waves, but not an expectation. And then the one that's due today is about earthquakes. And that's what we're going to cover today, is earthquakes as much as we can. So do we have any questions yet? Oh, no. We'll see if I can get this going. One more try. Oh, that's it. Okay, so let's talk about earthquakes. If you watched the video that you're given for this assignment, you can see that people are looking around because they're not clear what has happened, but they think something is happening. So that means that there was some sort of disturbance that let them know it's an earthquake. In fact, you can hear that in the video. Oh, that's an earthquake. And then the shaking really starts. So what's happening is that we have two different types of waves. Last time we talked about longitudinal and transverse. So we have two different types of waves that earthquake is transferring energy in. Now, the first one to arrive is the P wave. So that is the faster wave. That means a lot of the energy has gone into speed. So there is not as much left over to do damage as with the S wave, your transverse waves. So this is your longitudinal wave, the P wave. And the S wave is your transverse wave. It's slower and causes more damage. So this one arrives first, this one arrives later. If we know the difference in time between the arrival of the two waves, then we can determine how far away the earthquake epicenter, so the epicenter is where the earthquake originated, we can find out how far away the epicenter is. So if we look at the three different earthquakes on the assignment that were given, we can see that they've outlined the start of the first wave and where the second wave hits. And that's done on all three of these that are at different locations. So the way that we record the earthquake is a seismograph. So the seismograph is the machine that they have that determines the shaking of the earth. So now let's picture if I had one on the desk in the classroom, would there be any vibrations that would record that were not earthquakes? So if it's sitting on my desk and a student bumps into the counter, is there going to be a vibration that records? Well, yes. So what we do is we take that seismograph, and instead of having it at the surface where there are going to be a lot of interferences, street noises, people, cars, just regular everyday life happening, and we put that deep under the earth so that the vibrations from the surface are not being felt by the seismograph. The seismograph is measuring very minor changes in the earth. So that machine is very tightly bound to the earth, and there's a pendulum that hangs on it. So pendulum, that's something, if I was in the classroom, I'd show you a clip of some sort of a video. But there's a pendulum, so a weight hanging on a string, and that pendulum would be hanging still, but the machine is moving slightly. So that those disturbances are recorded on paper as if we're pulling paper through the machine at a constant rate, and we get a graph that looks like the one in your assignment here. All right, so we look at the arrival time of the P wave and the arrival time of the S wave, and the difference in the time, we multiply that by 8 kilometers a second, because we know that that's the difference in the travel speed of the waves. Now, let me say one other thing. S waves can only travel through solids. They can't travel through the liquids or the, well, I guess they can travel through air, but they cannot travel through liquids. But the primary waves can. They can travel through liquids. So they bounce around inside the earth in different ways, and we're not going to go into that. But if we take the arrival time of the P wave and the S wave of the first wave that we have here, so the first one is arriving at, I would say, 418. Is that about what you get? 418. Yeah, it's just under 420. So arrival time of the P wave I'm not spelling arrival correctly. Let's look at the arrival time of the S. Let's say 450. And the difference in the time, so I'll just put up my delta, 450 minus 418, so we have 32, and that's in seconds. And we multiply that times 8 kilometers per second, and that gives us the distance to the epicenter. I think my math is right. 240 and 16. Yeah, that's 256. Oops, I'm sorry. So we have the arrival of the P wave was 418. The arrival of the S wave was 450. The difference between them, that's 450 minus 418, gives us 32 times 8 is 256. My math might be off, but I think it's right. So you get the three distances to the epicenters. And then, because you know 3 different locations, you can triangulate where the epicenter is. So on the map on page 3, there is a scale, and I believe that's 1 centimeter is 60 kilometers. I'd have to get a ruler out to measure it. But we'll take the map that has a location of the different sensors on it. It's actually this way, isn't it? So we have sensor 1. Is that 2 or 3? That's 3. And then 2 is over here. So using the scale is right here on your page. This is 0. So this distance is 60 kilometers. We had 256 kilometers. So we would have to say that 1 centimeter is equal to 60 kilometers. So we want to know the number of centimeters we have to measure away from the center. We want the centimeters to be on top. And we multiply that by the number of kilometers away. So in number 1, we said 256 kilometers. Our kilometers cancel out, but we have to divide this by 60. Uh, 624, 16. Yeah. Oh, that must be millimeters. I'm sorry. Okay, so we have to measure this many millimeters away from the sensor. This is sensor 1, so that's this one. You take your ruler and you measure 42. No, I think it is centimeters. Yeah, it's centimeters. I don't know. You'll have to measure this distance. And you measure the distance away from that. You can use a string that is at length with a pencil on it, and every place has to be exactly that distance away from the center of the X, okay? So if you want to use a ruler and just keep marking points that are that far away. My circle's really off. Those points look better, and then connect those. That's how you would do it. Then you would do the same thing for this one. So you would get a circle coming away from here. So that means that there are 2 points that could be the epicenter, here and here, because they're the proper distance from this one and the proper distance from this one. Then you do your third one. And tell me your map, let's say that this is our point. and you measure distance from the third one. You have to draw your circle all the way around, right? So that's how you would do the triangulation. But do you see that if we know 3 different locations of the earthquake, we will be able to find out where the earthquake originated. So that's pretty much what I had to say about earthquakes today. We can measure magnitude and we can measure intensity. We have different scales to measure magnitude. It always used to be the Richter scale, but they've gotten away from that in recent years. And there are other scales that they use. It depends on where you're getting your information from. Okay, yes, we're calculating the kilometers away from the epicenter, but you have to use the scale that's on the page. I don't know what this distance is. This distance that's in the top left corner, you have to get a ruler to measure that. You see. Yeah, this should be a centimeter. It should be a centimeter, but I don't know what this distance is on a ruler. But whatever this distance is, that's equal to 60 kilometers. Okay, so that's how you do your conversion. You have to multiply by the number of kilometers and divide by 60 to get how many of these distances away from the center of the epicenter. I'm sorry, away from the location of the sensor. What else do I want to say about the Richter scale is logarithmic. So an earthquake that measures 5 on one of the scales that are used to measure the magnitude of an earthquake, then a 6 is 10 times greater than that. So there's a big difference between an earthquake of 1 and an earthquake of 2. It's not twice the magnitude, it's 10 times the magnitude. And then when you go from 2 to 3, another 10 times the magnitude. So a 3 is 100 times greater magnitude than a 1. A 4 is 1,000 times greater than a 1. A 5 is 10,000 times greater magnitude earthquake than a 1. Okay. Next week, we will be having 2 assignments. You'll have a quiz on waves and one assignment that you take a look at different phenomena, and you're going to do an in-depth look at that. So whether you want to develop a PowerPoint or a Prezi or some type of presentation, or you can do a video, or I don't think we're going to do social media post, but some sort of in-depth look at that. And again, you can work with 1 or 2 other people if you choose to do it that way. But those are the 2 assignments that you have for next week. I'm going to post them as soon as they are ready to be posted. And then you have until next Thursday to do that. I'm planning on doing a Zoom meeting next Friday so that we can celebrate. If you want to bring food, you can show everybody the food that you're having for your end of year celebration. Some of you are graduating. So I will send out that information on Remind. I will also post it in Google Classroom. I know not everyone is on Remind, but most people are. So we're wrapping up here. We have next week. Monday is a holiday, so no YouTube on Monday, but there will be YouTube on Wednesday. And then for Friday, we'll do our party, and that will be a Zoom. All right. And then you have, I want all work turned in by Thursday next week. So I believe that, what's today? That's the 28th, May 28th. I want all the work turned in. Okay. So have a good weekend. Have a happy holiday on Monday, and I'll see you on Wednesday. Thank you.